Hello, so I'm going to demo our private cloud, which we've called Condenser, because it's taking the cloud and turning it into water. Um, and it's built on top of SUSE, Rancher, and Harvester. And Rancher is basically SUSE's version of Kubernetes, and Rancher adds KubeVirt into that, so you can have VMs and containers all operating in the same sort of networking space and using the same tools to control. Um, our plan for this is that people will provision things programmatically using Terraform and Ansible. And I spent the last week looking at how to rewrite the course material we've previously done in AWS for a course I teach called Engineering for Data Scientists. Um, how to do that with Terraform and get that stood up. So if we look here, I have a bunch of folders in this repository with different environments and how to set them up, and they're all based off the base environment. The base environment is just Linux 9.4, which Ansible then updates to the latest, installs the latest security updates and patches, sets the locale properly, and then installs some tools like the full install of Vim and Emacs and Git and all the other bits people might need to use to do their work. Um, there's a folder here called C&C environment. That's for command and control. That's got some additional stuff, setting up both Terraform and optionally the kubectl tools. You don't actually need those for Terraform to control a ranch or harvester cluster, um, but they can be quite interesting for poking around. But for my teaching, I teach in this first term Docker and Kubernetes. And so I've got some information here for standing up a VM for the students with Docker all set up and ready to go. And similarly, setting up a small Kubernetes cluster with K3s. So let's do the Docker one. So if we look in here, there's actually kind of two control systems happening at once. So well, three if you include cloud init. So there's a cloud init template. This just tells cloud init how to provision the machine. And as you can see, what it does is it adds the code ready builder repo, the epol repo, and then also the Docker yum repos and sets up the authorized keys appropriately. There's a bunch of YAML files which are to do with Ansible. And then the actual Terraform stuff is, in this instance, 5 files. This is actually based off an example my colleague Ben Thomas wrote. It's not hugely different. So the main Terraform file, this is where most of the work happens. It has all the routines for telling Rancher to set up the machines. Versions and providers tell Terraform what plugins it needs. So the first thing you would do is do Terraform. Oops. And what that does is look at those files and make sure it's got the providers it needs. In this instance, it needs a random number generating provider and the provider for Harvester, which is the VM part of Rancher and Harvester. Outputs tells it what things you want to be able to get out of the system. So in this case, at the end, I wanted to print the IP addresses of the virtual machines and their names in the provisioning environment. Finally, there's a Terraform file called variable. And what that does is it sets some things that you might want to change. So it sets which operating system. So this is currently the latest image for Alma Linux we have installed in there. The namespace, this is the namespace for the course, and default network, and the number of VMs. And finally, you can do this in a bunch of ways. And these are variables that are used by main.tf, right? They're not like some special magic values. Main.tf uses them when it's provisioning systems. So in Ben's version, he sets a prefix name for the VM and the key ID separately. I thought to make it easy for keeping track of the students, we'll get them to name their key in Rancher after their UCL user ID, and then have them set a username here, and then the machines will automatically have their name embedded in the machine name as well. You can see that the default is commented out, and this means it will ask me for a username when I run Terraform. This system is still not quite in production yet, so there occasionally are some timeouts when doing Terraform things. But the nice thing about Terraform is you can just repeat the action to I'm not sure Terraform there to finish it, gets it to finish doing things. So let's do Terraform apply. It's just asked me for my user ID. I actually have a key in Rancher, which is inside that namespace, which is named after my user ID, which is UCCAOKE. Then it gives you a long list of what it's going to do and asks you to confirm that you want to do it. It's quite good because the inverse of apply is destroy, which will tear down all your infrastructure, which is slightly scary. I think this time we're actually going to see it time out because I have the GUI here as well, and the VM has not appeared in the GUI, which is usually a sign it's going to time out a bit. Yeah, this happens. It's nothing to be too worried about. There we go. I can see in the GUI it started up. We're currently investigating that timeout. It could be something in the so that API endpoint is behind like a redundant set of servers. One of the machines might be unhappy, so you're randomly getting a down one, or it might just be that 10 seconds is a very short timeout. Um, but I can see on the dashboard that it's created the VM and that's slowly starting up. Okay, so you can see at the end it spat out the VM ID, and if you were to look in the Rancher GUI, you see that's the UI, that's the VM ID. You can see it's got my name embedded in it, and then the IP address as well. We can actually log into that machine now. So that's the machine that really exists now. Um, that's only partially set up, so all that's done is the stuff that's in cloud in it. If we want it to be ready for a student, we then need to run it through Ansible. Um, One of the nice things about the outputs thing is that you can run Terraform at sort of any point after you've done the apply, and it'll show you that again. So if you've lost it, you've logged out and you've lost and scroll back, you can get the information back. But what I also have is a script which creates a Ansible inventory from that. And so you can use that to automate the inventory stuff. So now if you do Ansible playbook SI and full. What it will do is run that script to create the inventory, which in this instance only has one machine in it, and then it'll run through the tasks. Because I want to show the students the stages of setting things up, I've written these playbooks. So there's like a full which does all the tasks, and then a set of subtasks that can be run individually, so that you've got a choice, right? So the first thing it does is it updates the packages, it sets the locale properly, um, and then it should do a reboot. This is an extremely new image of Alma Linux. I think it's like 3 days old, so there are not many updates to install. Earlier this week, we still had a image from May in there, and it took considerable time to go through the update stage. I'm now rebooting. That's because when we had the bigger updates, it included things like kernel updates, and make sure, and particularly it included fixes for those OpenSSH vulnerabilities we had earlier this year, which were super not fun. So I wanted to be super sure the machines were up and running the new binaries. Bit belt and braces on Linux, but there you go. The machine is back up now, and it's going to install things like Vim, Emacs, Ansible, um, also Screed and Tmux. And I think like the bind utils and things like that, just so that the machine has some of the stuff you might like want to use when you're debugging something that's not working, because the students will find that things break, and having things like next stat and ping will make your life a lot easier. After this, it will install Python 3's pip and virtualenv. Um, and the development packages for Python, because those are both really, those are all three minimum requirements sort of for Python to work properly. Um, then it's going to install a Docker tool. So we already have the repository in the cloud init. But so what it's doing now is it will install the Docker packages from that, and then it will enable the service and add the user to the right group so they can run Docker. Okay, that's finished. So now if you log back into that machine, we should just be able to run Docker, right? Docker PS. Obviously nothing is running. But what we can do is test it with like this with a canonical Docker tests. So obviously the first thing you're supposed to do with a new Docker install, prove that it's all working and set up, is run hello world. So let's do that. So that will pull the container down and run it. So that's the hello world container. We can run um, Julia or maybe Ubuntu. Let's do Julia. Uh, So, I mean, this is all set up and ready to go, right? So then we can teach, I can use this then to teach the students about creating containers, stuff about like container lifecycle, that kind of thing. Um, Fantastic. Okay, let's get out of here. So the other nice thing about Terraform is that when you're finished, you can just destroy your infrastructure with Terraform destroy. And it will go away and destroy all those VMs. And we can get on with our lives. So that was one machine. That's not too impressive. More impressive is setting up an entire K3S cluster. So I also teach Kubernetes, and you might ask, well, this entire system is Rancher and is Rancher, which is Kubernetes. Why not just use that? And part of the point of the course is so students how to set up and somewhat break infrastructure. We don't want them doing that on the main system. So what I've done in previous years, and will do this year, is provision a Kubernetes cluster inside a set of VMs for them to mess about with. The setup here is basically the same as it is on the other cluster on the Docker stuff. So we just do Terraform. I've run it before, so we don't need to do the init stage. The main difference is I've actually put my user ID in that variable. So hang on, let's get out of there. So I'll show you. I've actually set my user ID here, so it won't ask. It is now standing up 4 VMs. They might not all start the first time because we're still having some weird load balancing issues on the API endpoint. It's weird. It seems to happen with Terraform, but not with the GUI. So there's something funky going on. You can definitely see that the fourth node doesn't appear to have been created, so it's going to time out. The amusing irony of recording videos. I did a recording of this earlier, but I did it in the main office and I was too quiet, so it wasn't really audible. And everything worked first time, so fantastic. Okay, so it timed out creating one of the VMs, the other three are up. So as I said, you can just do apply again, it'll finish off There we go, the fourth VM has in fact started up. Okay, so it's finished. We have our output with the machine names and the IP addresses. And this has got a slightly different version of the inventory script, which will actually split things into workers with three of the nodes and a head node with the fourth node, right? Because you want, like, I think in the parlance of Kubernetes, it's the server is this machine, and then these machines are agents. Um, but just in the same way as before, we do Ansible and leave it to go away and install. So it will do the same routine. It will update the system, install the quality of life packages, and then install Docker because you want Docker as well as K3s because you want something to let you create um, containers in your little mini cluster. I prefer Podman, but we teach Docker because it has more sort of name recognition for the students. Um, also sort of easier. Like, let's be honest, part of the reason people do computer science courses is to get a good job, and being able to say you've got experience building containers with Docker is a much better CV thing to have. One of the changes, as you can see, we're using Alma Linux here. When we took last course last year, we used Red Hat. We have like a site license for Red Hat, but it's because of the way Red Hat Subscription Manager works. If you're starting and stopping VMs, it's a real pain because it locks you out of the ability to add packages until it's registered with the subscription server. Um, and although we're licensed, the way the cloud and images for Red Hat works, they pick like a random period of time before they try and register. So you basically have to either wait for that random time of up to a couple of hours for that task to fire off, or do some kludging to manually fire it. And it means that you have to, at this point we would already be stuck because we couldn't add EPEL or the Kubernetes builder repositories. We'd have to wait for the nodes to register. Pain. I don't know. Like, I like the Red Hat ecosystem, which is why we're using Alma Linux, but I think it is frustrating that most of the pain of using Red Hat is caused by having paid for Red Hat. Like, it doesn't feel like you're getting additional value out of it. You're just getting pain. So, although in theory we're licensed for Red Hat, and in fact, underneath here, I believe the base operating system on the Rancher nodes is Red Hat, and on the Harvester nodes is like mini SLES or something like that, micro SLES. Uh, it's just not worth it in an environment where starting and stopping infrastructure. I don't know how Red Hat can fix that without radically changing how their license server works. One of the things I should probably change here is change it so it only installs Docker on the server slash head node, because we don't really need it on the other three. But whatever. Right, so what it's going to do now is on the head node only, it's going to do. So the way you set up a K3s cluster is you set up the server, or in my mind, head node first. Um, and then it generates a thing called a node token, which you use to join the other nodes to it. So what we're going to do is we're going to install K3s and Helm, because we use Helm to show the students how you can automate deployments of things like Jupyter Hub on top of K3s. We're going to install install K3s and Helm on the head node, and then it will install the three worker nodes and attach them to the cluster. I apologize. The original versions of this, which ran on top of AWS, I wrote last year when I was feeling somewhat unhinged, and so all the task names have emoji in them. I apologize. Um, So what it's done there is it's got the token from the head node and pulled it back to a local file. And now it's going to start setting up the worker nodes. And this pattern, so in the second term, I teach stuff around traditional HPC, so how to set up Slurm and BGFS. It will be exactly the same as this, right? Both of them work by having like a secret token that you share between the nodes. In the case of Slurm, it's the Munge token. In the case of BGFS, it's an authentication token. And I've got already setting those up is already written from last year. I will just modify it so it uses, so we use Terraform and Cloud in it to provision the nodes originally. Okay, in theory, that's done. So if you remember what the head node's IP address is, and I can't because my brain is rubbish, we run the generate. Right, it is 10. Okay, so let's log in here. And now if we do kubectl get nodes, we have all 4 nodes in the cluster. Helm is installed, so we can do automated deployments. So that's all ready for the students to use, and that's quite nice because previously setting this up with them in class was even the way I've done it. I'll log out now. If you look, there's a lot of different YAML scripts, and they're called by sorry, lots of different Ansible playbooks. And there's a master one called full, which calls the other ones. And it's these 2 steps could get quite sticky with the students previously, but having a nice automated way means that if they get stuck, you just run the full thing, and they'll end up with a working system for when they need to do the next steps. So, as before, we just do Terraform destroy to tear this all down. And we say yes. And that's it, really.